Okay, now it's recording is going on. That as I mentioned that the last day we discussed those basic parameters and we did nearly 3 to 4 questions to try those things. And I'll share my screen. And you can see this one. Then we those are the things we discussed. This AC/DC waveforms and the voltages AC/DC and currents AC/DC and power energy. Those are the things. And we identified the AC/DC waveforms also. And after that, when it comes to that AC volt power, then we discuss about the RMS component of the AC signals. Okay. Okay. Then we discuss this RMS component and how to take this RMS. Uh, okay. Then shall we go back to the questions? Then these 4 questions we discussed, and we can start from this one. Okay. You may identify that when we power up the circuits, that basically when it comes to power sources, we have AC power sources and we have DC power sources also. But normally that when the AC power comes, that it may be the main power coming to our homes. And at the home front, we have the main power, the commercial power available is a 230-volt DC. So we can mention the frequency value also 50 hertz. That's the main power. But this voltage is a very high voltage for the circuits. Okay, what we are doing when we have this power, most of the time that we have this AC power source, AC. Then from this side we are receiving 230-volt AC power. Then after that we convert this AC power into DC. Then from this side we have maybe the whatever the positive voltage DC. Okay, it may be plus 12 volts plus 5 volts, or maybe the plus or minus 12 volts like that, maybe the 24 volts like that. Different DC voltages are coming from this side. Then, when this is our circuit, those circuits are, they are expecting DC power, the DC voltages. Then we can give this DC voltages to this one. That's how this, the most of the time, 99%, 95%, the devices are, the circuits are working with DC voltages for your mobile phone, with whatever the circuits we are having, the radio circuit or the remote control circuit, or with the different, maybe for example, if you consider the washing machine controller, maybe the air conditioner controller, some of the controllers we are having that as a user interface. All these circuits are, because that they are sensitive components are there, ICs, capacitors, resistors, diodes, transistors like that. For those components that we need DC voltages, then when we have the main power, although we mentioned that AC power sources are there, after receiving this AC power like this, we convert this AC into DC. Then inside that circuit also, this will happen. Then after converting this AC voltage into DC voltage like this, then those we can feed that DC voltage here. And when it comes to DC power sources, then most of the time batteries are there. Batteries. When it comes to batteries, that we see, we have the lead acid battery. The different varieties of batteries are there. The fixed voltage batteries, you can see that the tri cells, and maybe the rechargeable cells, rechargeable batteries, and these lead acid batteries, and the maintenance free lead acid batteries like that. A lot of battery varieties are there. That these days are very popular battery type is a lithium ion battery. Before that, we had lithium ion battery, we had nickel cadmium batteries also. I'll provide a small note regarding these batteries and what type of batteries we can use those things, and I then you can have this lecture material. But that's for your information. But most of the time, the batteries are DC. Then we can directly provide that power to the circuits also. Okay. Some circuits are working with AC voltages, and then sometimes that after reducing this one, again we can provide this 230 volts AC, but comparing this voltage is a very high voltage, but some of the circuits are providing the low, this voltage may be AC, but these are low voltages. Okay. Then this time, then this is AC, we are providing AC, but the output is also AC. But again, this as comparatively, this may be 12 volts AC and 6 volts AC like that. The small voltages are there. This is sometimes some power supplies are converting like this also. Then some couple of circuits might work with AC voltages. Then when they need AC voltages, we can provide this one. For example, electrical iron at your home front, electrical heater at your home front. They are directly working with AC voltages. That when you plug into 230 volt AC outlet, then the iron is working at 230 volt AC, and your heater, water heater, it will take 230 volt AC, and it's working with this AC voltage. It doesn't matter, it is not necessary to convert those things into DC. But I am telling all these for your information. And but some of the ICs and transistor diodes are, if the circuit are containing those sensitive components, most of the time, probably the voltages are DC. I am telling all these things because that you have identified that a lot of power sources are available. Your one of your batchmate has mentioned on the chat that, sir, we were told that today is a physics lecture, not electronics. But in my timetable, this Sunday 10:30 to 12:30 slot is for this part. I think last Sunday also we had the same thing, didn't we? Hello, can you hear me? I think you might have some kind of confusion that I am doing circuit theory. The circuit theory part is coming under the physics module. The part of the your physics module, the basic stuff for physics may be part of that one with the fundamentals of physics. The other half of that lecture series is the circuit theory. Actually, this is not electronics, but in the electronics module, that the basic electronics for the chemist, that's analog electronics and digital electronics, and I am doing that digital electronics part under that module. I think this module may be the module code is, and this is the module code, isn't it? With this module code that I am doing the circuit theory part. It's okay. Okay, shall we come to the lecture again? Then these are the power sources. When I am telling all these with the different time here that you can see the power source supply voltage is DC 10 volts and the resistance 200 we don't mention specifically about the power source, but you can see the DC 10 volts is provided to the circuit. Okay, but here you can see when plug into 230 volt AC, here the power source is 230 volt commercial power. Okay, but here in the fifth question, our power source is a battery. The battery delivers 24 volts to a bulb. Like that, we are using different power sources. That's why I mentioned here the different power sources are there, but sometimes that the connectivity is something like this. DC power sources, we can straight away, we can directly use the DC power sources as it is, because the voltages are low voltages are when the voltage is DC. But when it comes to this AC main power, sometimes that we have to convert this 230 volt AC into small DC voltages or maybe small AC voltages. After that, we can use those power supplies to feed power to our circuits. Okay. Then for this batteries, this one, for this one, I'll provide a maybe separate note for batteries, explaining the battery types and the purposes we are using and like that. But for your information, then you can have that those things with your as a reference. Okay, shall we try this one? Okay, before you do those things, what you can see, can you read the question? A battery delivers 24 volts to a bulb. The current in the bulb is 3 ampere. Okay, we can figure out that one. Then we have a bulb, then the power source is 24 volts. When you uh, power up the bulb with the 24 volts power source, the current going through the bulb is 3 ampere. Then we are asked to find resistance of the bulb. Easily you can put the Ohm's law, you can find the resistance, the voltage of the bulb, then you know the voltage, you know the current, then you can find the voltage. And the see the third part, if the bulb is connected to the battery for 1.5 hours, Find the amount of energy received during the period in watt hours, kilowatt hours, and joules. What is that part? So far, we didn't discuss this one. Then here, in the first part of question, we are talking about the voltages. Voltage is 24 volts. The current is there. Current is 3 ampere. And we are supposed to find resistance. Then R is there. Then current, resistance, and voltages. All three parameters are there. After that, we have to find wattages, W. Okay. Then, but still we didn't discuss this one. Then we have to find energy also. What is the energy? What is the difference between wattage and energy? Wattage is, now we have V, we have I, and we have R. Then you know how to find these things because that we have relationship, Ohm's law, very simple thing. From this one, we can find any of these things. Then after that, we have wattage, so W. How can we find W? Then VI. Okay. But you know this V in different forms, then you can apply this one. Then this one. But we replace this V using IR, then this is I squared R may be there. And if we replace this I by V divided by R, then this relationship may be there. Okay. Using whatever the equation you can find W. But this is the basic equation. What I have done here is that we have replaced this V using V equals IR, then IR is here, another I is there, then I squared R. Then here in this case, I have replaced I equals V divided by R. When it comes V divided by R, then V squared R. Whatever the equation you can. And what is energy? How can you find energy? Then if you use this wattage, maybe we can say power. P. Energy means P into T. This much of power, this much of power, if we use for this much of time period, then energy is there. Then for the units, what are the units? From this power, we have W. From this time, we have seconds. Okay, but second is a very small unit. Then we can convert these seconds into hours. Then watt into a kilowatts like that. Okay, I'll go to a particular slide. Then you can easily understand this. And I have prepared a special slide for this one. Shall we look at that one? Can you see the screen? Then power is the rate at which energy is expanded. Power distributed over length of time. Then normal unit we are using in physics, joules, but joules is the watt of wattage dissipated for 1 second of time. Okay, but this may be a huge figure when you calculate joules. Okay, then it's a This one, normal this joule, watt into seconds. Okay, but then it may be huge figure. Then because of this, we are converting this watts into kilowatt hours. First one, that can we convert this one, this seconds into watt hours. This is joules, and this one watt hours. Okay. The simple meaning is that we are converting these seconds into hours. So we can divide this one by 60, then it will be minute. Then after dividing it by, then it may be hours. Then we can convert this figure into watt hours. But sometimes this figure also may be a huge figure. Then we can convert this watts into kilowatts. Then we can convert this. We are converting these seconds into hours. And here, this is kilowatt hours, and that is you're converting this wattage, this one, into kilowatt. Then we can when we divide this watt by 1000, it will be kilowatt. Then if the figure is a very huge one, you can use kilowatt hours, especially that at our home front, to measure the how much of energy you have used with the commercial power supply. In our energy meter, we are placing in front of our houses. Then the unit is kilowatt hour. One unit is a kilowatt, 1 kilowatt hour. Then if we use 1000 watts per hour, 1000 watt per hour, it may be 1 kilowatt hour. That's why I'm measuring the units. Okay. Okay. Shall we go back to the question? Is it okay? When you do this example, you can easily understand, and it's not a new thing. Can you see the question? Shall I try it? Shall we try this question? Hello? Simple one. Then we have a battery. It's a bulb. Then battery voltage is 24 volts, and the current going through this one is 3 ampere. Then using this Ohm's law, we can find this is 3 ampere, and we have to find R. And this is 8 ohms. Okay, first part 8 ohms. Then voltage of the bulb, W V I. Then V is 24 volts, I is 3 ampere. Then this is 72 watts. Third one, if the bulb is connected to the battery for 1.5 hours, find the amount of energy received in the period in watt hours, kilowatt hours, and joules. Then in energy, then time, in plus part, the wattage is 72. Then we are providing it to watt hours. Then how much of hours? 1.5. Then 72 watts. Then 1.5 hours. Then how much it? 8 watt hours. That is 1 hour. Then we have to convert this one into kilowatt hours. Kilowatt hours. To convert this wattage into kilowatts, then we have to divide this one by 1000. Then 108 divided by 1000. Then it will become kilowatt hours, because we have divided this one by 1000. Then what have been converted into kilowatts. Then this is 0.108 kilowatt hours. Okay. Then we have to convert this one into joules. To convert joules, this one into, we can take, this is 108 watt hours. Then hours we can convert into minutes by multiplying into 60. Then we can multiply it by another 60. Then this hours will become seconds. Then this is watt seconds. Yeah, joules. Is it okay? Same energy measurement, but in different three different units. Okay, this is in watt hours. Unit is watt hours, and this one is in different one, but this is unit is kilowatt hours. This is the same thing, but in joules. Any question? Anything regarding this? Okay. Then shall we try this? The same thing for AC power. The previous one, the power source is a battery, but here power source is commercial AC power. It's like previous question. Now the supply is AC power source, then you have water heater. Power source is AC. Heater. This is 230 volt AC. We have to find the current. This one. Then the heat wattage is 1000 watt. Okay. Then you know that the power equation W equals VI. Then wattage is 1000. Volt is 230 volt. And we have to find current. Then I volt. It's 4 point. We can approximately take it as 4.35 amperes. Then if the head is used for 2 hours per day, find the amount of energy used during 1 month period in watt hours, kilowatt hours, and joules. Now this is part one. It's the current and amount of energy. We can find energy 1000 watt. We are using 2 hours per day. Then for 1 month. Then 30 days. Okay. Then this will be 60,000 watt hours. That is in watt hours. And we can convert it into kilowatt hours. Then 60,000 divided by 1000. Then it will become kilowatt hours. Then this is 60 kilowatt hour. Okay. If we convert this one into joules, then how much watt hours we have? This is 60,000 watt hours. We can convert hours into minutes and into seconds. Then this is much of joules. Let's say one, 260, 1, 2, 3, 4, 5, 6. You can see that for joules, that huge figures are coming. That's why we are converting this into watt hours. Here also you can see the 60,000 watt hours is there. That's why we are converting these watt hours into kilowatt hours. Then it will be a small figure. Is it okay? Now, these are the basics that we are going to discuss. And with this Ohm's law, you should be able to calculate whatever the value V, O, I, O, R using Ohm's law. Then after that, the voltage is coming. Then with the equation W equals VI, then O will be the different flavors of that one using putting the VIR equal that one. Then we should be able to calculate the voltage. Then after that, when the voltage is involving, if we apply that much of power for a certain period of time, energy is coming. Then we should be able to calculate energy. Then after that, the unit conversion. Energy, original unit is joule, then we should be able to calculate into watt hours or kilowatt hours. And those are the basics we are having. And shall we try those things? Shall we try a different question? With this, again, we are that that when we have the couple of resistors there, the depending on the connection type, we should be able to find the equivalent resistors of the circuit. And now we are trying that one also, refreshing those things. But we have here we have three resistors, and you have to find total resistance R. All these three resistors are connected in series. Then you know how to add those things. Then after that, you can calculate current and voltage across each resistor. If you know the current, you can calculate the voltage and power, do it, and power delivered to the circuit by the voltage source. Okay, shall we try this one? This is again very simple. I think the total resistance we can find the total resistance R we can find adding R1, R2 plus R3 together. Then this is 6 plus 4 plus 10 is 20 ohms. Then section B, current I. Then we can find current I going through the circuit. All the resistors are having the same current because it's a series circuit. Then I we can find divide V by R. V is 36 volts and resistance is 20 ohms. Okay, then this is 2 36 divided by 1. This is 1.8 amperes. Okay, the voltage across each resistor. C we can find VR1. VR1 means that I into R1. I means here 1.8 ampere. R1 6 ohms. This is 10.8 volts. Then we can find VR2 and VR3 also. VR2 I into R2. You can find it. This is I into R3. Huh? Then voltage across each resistor, we have found that one, the power dissipated by each resistor. Then R1, then we can find using VI. This is VR1 into I. VR1 10.8 volts and 1.8 amperes. This is 19.44 watts. And then P R2 VI, then VR2 into I, VR2 7.2 volts, I 1.8 ampere, then 7.2 into 1.8, 12.96 watts, then P R3 VI, VR3 into I. VR3 means 18 volts into 1.8 ampere. 18 into 1.8, and 32.4 watts. That is B. Power dissipated to the circuit by voltage source. E. Power total 36 volts into 1 point. Actually, the power dissipated by the battery 1.8 ampere. 36 volts into 1.8 ampere. 0.8, then 64.8 watts. Then we have to F. This is power battery, and we can find the R1, PR2, PR3. That is 19.44, 19.44 plus 12.96 plus 32.4. 19.44 plus 12.96 plus 32.4. Then this is 64.8 volts. These are the individual contributions from each and every resistor R1, R2, R3. These are the power consumption. When we add these three things together, this is the total voltage consumed by received by these three components. And when we find that the total battery delivered to the circuit, this much of power the battery has been delivered to the circuit, then those two are equal, then we can say the resistor equal to the power delivered to the circuit by the voltage source, both are equal. Anything? Any question? Okay, now I think you can handle these type of questions. I think other important two laws are there, and we can, I think, simply mention this one. The Kirchhoff voltage law. So according to the Kirchhoff voltage law, then if you have some kind of voltage source like this, And if this is the voltage V1, because this one V2, V3 like that, the Kirchhoff voltage law says us the algebraic sum of this each and individual component of all these things is equal to the main voltage source. Simply something like this. This V equals V1 plus V2 plus V3. These are algebraic sums. Okay. And this voltage is in this direction, and this direction. We have to think about the signs also. Then this V equals to V1, V2. You can see that the V1, V2 in one side and V is in the other side. Okay. That's how we can actually Kirchhoff voltage law says theoretically it says something else. That algebraic sum of all the voltages in a certain loop is zero. Okay, we can say that one also. Okay, this V minus V1 plus V2 plus V3 equals 0. But simply you can say in this form. Okay. The current law, Kirchhoff current law says us if you have nodes something like this and the different branches are having something like this, the total incoming currents for a particular node, then this I1 plus I2 equals I3 plus I4. In simple terms, you can say the total incoming current, the value is equal to the total outgoing current. Okay. Another way, I1 plus I2 minus I3 minus I4 is 0. Okay. But you can use this one and this KVL and KCL. These are another two important theorems we can use when solving these circuit theory problems. Okay, having said that, shall we try a different problem? Something like this. You have a power supply is 12 volts and it can deliver 2 ampere maximum to a circuit, and it has been connected to the circuits having couple of sub circuits. Then from the main power supply, the pre-amplifier circuit will take 60 milliampere, LCD display will take 15 milliampere, power amplifier will take 1.2, and 35 milliampere is drawn by LED indicators. Okay, then the question is very simple. What is the total current supply from the power supply? And what is the reserve current available? How much of reserve current? Okay. Shall you try this? Okay, two questions were raised. Didn't you hear that when I explained this KVL and KCL? Have I muted my microphone there? The one question was raised that when then why this 50 hertz given in the question? Is it additional data? Yes, we are not. That if it is necessary that we can use the 50 hertz, that when normally that when we mention that AC power, we are mentioning the frequency also, the 230 volt AC 50 hertz. But so far in any question that 50, although that 50 hertz has been given, but we didn't use. But when anyway that when we mention the AC power, normally we mention the question with frequency value also. If it is not necessary, you just ignore it. It's additional information. The other thing that should we remember these definitions by heart? But normally that this Ohm's law V equals IR, it is not. I think it is all of you know those things. That one. And P equals VI, the power equation. How can we calculate power? And the other one is KVL and KCL. All the voltages in a particular loop, that when you have power source at all other the voltages developed across the components, you can add all these things together, it will be equal to the main power source value. And the KCL, current law, that all the incoming currents, the total incoming currents value is equal to all outgoing current value. Those are the very simple things. I think not only equation wise that, but you have to remember these concepts. But if you have that different equations, different set of equations which are not familiar all the time, those will be provided. But I think so far, Ohm's law, power equation, and how to calculate energy, and the other one, the KVL and KCL, they are simple things, and like that. I think I have muted my microphone during when I explained this KCL and KVL. Then I think it's better if I mention it again. This one, the Kirchhoff voltage law. I think I searched the internet and took this extraction from the internet. Then you can see that his voltage law states that for a closed loop like this, with the algebraic sum of all the voltages around any closed loop in a circuit is equal to zero. Something like this. Okay. The algebraic sum of, if you take a direction like this, okay, considering that all the direction voltages are in this direction is positive, the algebraic sum is that this is V and minus V1, V2, V3, Actually, this equation should be written like this: V minus, because that we are considering this way, but V1 is in the other way. Minus V1, then it is minus V1, minus V2, minus V3 equals to 0. But in simple terms, but you can see, in other words, the algebraic sum of all the potential differences around the loop must be equal to 0. This one. But although that Kirchhoff law is theoretically mentioned like that, the practically what we are doing is that we can take this V in this direction is equal to these ones. Okay. For example, in previous question, you can see this one. Here we have 36 volts. And what about this one? This voltage, what is the VR1? This is 10.8 volts. This voltage is the current is going this way, the voltage is the other direction. R2, R2 is 7.2 volts. 7.2 volts. Then R3 is this direction is 18 volts. Then the Kirchhoff's law says us this 36 volts minus 10.8 minus 7.2 minus 1.0. That is true, because that is a V minus V1 minus V2 minus V3 is 0. It should be 0. This is the Kirchhoff voltage. This volt, the theorem says us this. But when you apply these things, you can see that 10.8 plus 10.2 is a 1. Sorry, not 1.8. It's 18 volts. 18 volts. The algebraic sum is 0. Then simply what we are doing is that we can take V equals V1 plus V2 plus V3. This from this side we know that this is 36 volts. When you add all these three things together, that is also 36 volts. Then that is okay. That's why I mentioned here. Simply you can take this one as V equals V1 plus V2 plus V3 like that. But if you know any of these things, but one thing is unknown, you can find that one if you know all other three things like that. The KCL also like that. Kirchhoff current law, that is also same way. For example, assume that you have a circuit something like this. Okay, and this may be voltage and the current this current I is going through this way. Then here also we have I, and if you have I1 like this and I1 I2 like this, then you can say I equals I1 plus I2, very simply. So that this is the when you consider this node incoming current is I. The outgoing currents are I1 plus I1 and I2. Then I1 and I2, the sum of this I1 and I2 equals to total incoming current I. Or if you want that, you can put it to the KCL, that you can say like this. This is what law says us. But practically, we have this equation and we can apply this one to circuits. Same thing. Okay. Okay, now we can go to the question again. This one. And we have to find the values here. I think this is very easy. When you apply this KVL and KCL here, that actually it's a Kirchhoff current law. But without knowing this one also, we can apply this one. It's not a very difficult one. The main circuit, the battery is supplying voltages to the preamplifier amplifier circuit, LCD display, power amplifier, and LED indicators also. Then four sub-circuits are there. For this four sub-circuits, the circuit is providing the current like this. This is your power supply. This is power supply, and we have four sub-circuits. This is preamp, and this is LCD. This is power amp, and this is LED indicators. Okay, this is the positive voltage line coming to these circuits. This is the positive voltage line. And this is 0 volts line. Okay. This is the main current. The preamplifier circuit, this current is I1 is 60 milliampere. The LCD circuit, we can take it as I2, that is 15 milliamperes. The main power amp, I3, I3 is 1.2 amperes. This LEDs. I4, that is 35 milliamperes. The total current is I equals plus I3 and I4. Then this is 60 milliampere, 15 milliampere, 1.2 amperes plus 35 milliamperes. Now we can bring all these things into one unit. (1,500 milliamperes), 60 milliamperes. Sorry.
Excuse me, sir.
Yes.
So I think the screen is frozen, sir.
Screen is frozen. That means the Word document.
Yeah.
Okay. Can I share it again? Now, can you see it? Can you see it moving?
No, sir.
Maybe a connection issue. Can I stop sharing and share it again? Now you can't see anything. No? Again, that still you can see the frozen screen. Hello?
So we can't see the screen now.
Okay. Now, can I share it again?
We can see the question, sir.
Now?
Now we can see it, sir.
Okay. Okay, now this is the way. Then we have to convert everything into one unit. Then all these things are, this diagram is okay, no? That the main power supply can provide these four circuits. Then from this node, we have divided into four circuits, okay? Then 60 milliampere. This is 15 milliamperes, then 1,200 milliamperes, then 35 milliamperes. Okay. Then we can add those things in milliamperes. 1,310 milliamperes, 5 plus 5. This is in milliamperes, then you can say, oh, this is 1.31 amperes. That's the total current. Okay, then what is the reserve current available? It can deliver 2 amperes, but we are taking only. Is it okay? Any question? Okay, then okay, the previous diagram. This one actually, this is the power supply, and we are providing power to these 4 circuits. Then the total voltage and current is coming from this main power supply. From the main power supply, the pre-amplifier circuit is taking 60 milliampere. Then 15 milliampere taken by LCD display. Again from the main power supply, one power amplifier is taken by 1.2 ampere. 35 milliampere is drawn by LED display. Okay, then these 4 currents are drawn from the main power supply. Then I equals I1 plus I2 plus I3 plus I4. We are applying KCL here, Kirchhoff current law here. Okay, then this is the next question, but you can try it. Again, you have to apply Kirchhoff current law and KCL and KVL and these things. Then, but I think that with the available time that you can see that until that the next section comes, we have to do this 9, question number 9, 10, 11, 12, 13, 14, and 15 and 16 also. Okay. Then up to this question number 17, we have to complete before we start the next section. But normally, in the face-to-face session classes that I have, I am completed within 2 days. I am coming up to this point because the problem is that when I finish one question, I can see that all other classes, all other students in the class, how they have done all these things, they have completed or not. But here I can't see those things, and then I am allowing you to do have some kind of time to try those things. Because of that, the time is going. But up to question number 17, that these questions might take much more time than the questions so far we have tried. Uh, the practical problem is there because of that. The next day, I can take half an hour to solve these questions, whatever the thing. Within half an hour, we can try those things. Then after that, we can start the next section. Then we have finished actually question up to question number 8. 9 is also simple one. There is no problem. 9 for 9, but this 10 is also. These questions might not take much more time, but we have to explain, try those things before we come to that one. Then we can try those things within the first half, this first 10 minutes of the next day. Then after that, the other questions I can send it you, put in those things into the tutorial. But then we can later on we can have a different session uh, to find the answers for these things, or whether you can try, then we can discuss the answers. But we have to try these questions before we go into the next section. That's the important thing. Anyway, then shall we try that one next week? But if you have any feedback that you can give it to me, that the speed we are going and maybe the style we are following in the class, is it okay or not? That what do you feel? Those time of feedback is very important. Then I can, if you are okay with this, then I can speed up that one. Or but the speed is a little bit high, then we can slow down that one. Then we can find a different solution to address those questions. But your feedback is very much important. Uh, even though that you cannot mention it here, you can type on the chat. Otherwise, that maybe this is my mail address that you can write it to me. But anyhow, that your feedback is important to continue this way, or maybe to change the style. Okay, shall we finish the class? Then so that you might have the different session maybe after certain time period, so that it's not fair. I'm taking much more time beyond the limit. Only the thing that to get the maximum results, maximum benefit of the class, I think it's good that if you are try your own, then but that it's those are the sometimes that maybe the negative feedback of this online system. But in the class that I can see that how much of you have finished, that I can go to the places that you are sitting, that I can explain that then and there, then that facility is not here. But anyhow, that if you have try your own and if you try write your questions on the chat, then likewise that we can minimize the damage, we can minimize that those things, and we can try to take the maximum benefit of the class. Yes, I will. Yes, I will upload the class recordings, and maybe you can refer it again and again. Then you have, that is the main advantage of having these online classes. That recording is available to you. Then you can refer it again and again. Then if something you have missed and you couldn't listen, then you can take it. You can grab it later on. Okay, anyhow, that I will upload those things and I will send the link to the your teaching assistant, and she will send those links to you. the meantime, I think you have shared the batch reps email address with me. I'll send those things to you also. The tutorial I will prepare and send it to the your teaching assistant, and she will make the necessary things to, and she will make available to you. Okay, thank you very much for your time and have a nice weekend. Maybe